Hi Year 9, I'm going to go through your assessment, which is questions 1 through to question 20, and going to fill in a few details, a few things that people might not have learnt through their remote learning. I shall point out everything was covered in the remote learning that was set, and I've been available on Teams and through email to answer any questions. I'll show you examples of the sort of things that people have done. So you should have done task 207, where it asks you to work out the gradient and y-intercept for basic straight line graphs. You would have done task 208, which is given a picture of a graph, working out its equation. And for each of these, there is a video that you could have watched. You could have also asked for help at any time. And this goes all the way through to, let's just guess at this one. Is it this one? Okay, so for example, task 212, let's look at task 211. So, you know, questions where it tells you where it goes through, it tells you what the gradient is, write down the equation of the line. Now, this entire topic, we've been doing it now for a couple of weeks, and it was building on work that was done in year 8. So this was not absolutely brand new content. However, I appreciate it is hard to learn this at home. That's why I've been available all this time to ask questions. So, just before I start answering the questions from the assessment, let me give you a very, very brief overview of this topic, okay? I can't promise that this explanation is going to be the most perfect explanation ever. I'm going to try to do it quite quickly and try to get across the main ideas. So one of the best ways I can think to quickly explain it is it basically ties together two key ideas. Okay? So it's basically, if you think there's one thing to know about, and then there's another thing to know about, and to begin with, you can pretend these are separate. But of course, they're not. They're related, and so we also have to know how are they related. But let's talk about the two separate ideas first. The first idea is the idea of a gradient of a straight line. Now, I have a playlist that I made back in June 2020 that talks all about the gradient of a straight line. I shared that on numerous occasions on Teams. So I would have hoped that most people have watched this series of videos. It will also be linked down in the description of this video. But I will say something about it now. So basically, you fix a horizontal and you fix a vertical, because if you don't have a horizontal and a vertical fixed, then you draw a random line and you can rotate around the paper and you can affect, you know, is it going uphill, is it going downhill, is it flat, is it pointing upwards? You're not allowed to rotate the paper, okay? You have to have an idea of what horizontal is, and you have to have an idea of what vertical is. So once you know what the horizontal and the vertical are, you can draw some straight lines. So for example, if I draw this straight line, just take that as an example, I can ask some questions about it. One question I can ask is, what is its gradient? And so if you've watched the video or the series of videos that I made, there's only 3 in the gradient playlist. We can actually say something about what the gradient of this line is. First of all, it's just a number. So it doesn't have any units. It's just a number by itself. And basically, it's how steep the line is. If it is pointing uphill from going left to right, so if over here is obviously left, over here is right, and I'm going to be moving left to right, like how a number line goes from the negatives up to the positives, from left to right, also how we read sentences from left to right. we are going to consider this as going from left to right. So if I start at the bottom of this hill, and I'm going to be going left to right, I'm going to be going uphill. Okay, so uphill. So first of all, if it's an uphill line, it's got a positive gradient. If it's flat, it's got a 0 gradient. So for example, if I draw this line here, if you imagine that you're walking on this line, you're just walking on flat ground. You are not having to put any effort in, really, because you're not going uphill and you're not going downhill. So the gradient of a flat line is 0. And if it is going downhill, then it's got a negative gradient. So for example, all of this, by the way, is completely covered in the videos that I made in June last year. If it's going downhill, then we'll say it's got a negative gradient, okay, as I wrote there. And so then there's a question of, okay, maybe it's going uphill. Is it very, very steep, or is it quite close to being flat? Basically, the bigger the number, the steeper it is. Okay, so if I get rid of these drawings and just draw a couple of examples, and let me just draw it very quickly so I'm not worrying too much about it being very neat, although perhaps I can. Can I draw a straight line? Insert shapes, straight line. Yes, I can. Right, great. So, and let me make that a bit thicker. There you go. So I've actually got a straight line, which is good. So okay, these lines I've just copied and pasted there. These would actually be considered parallel until I, of course, change the gradient of this one and maybe make it go like this. Okay. And so the question is what are the gradients? Well, they're both uphill, so they both have positive gradients. However, if you were walking up this hill, it would be a lot harder than walking up this hill. This hill here has a steeper is steeper, so has a bigger number for the gradient. Okay, has a bigger number for the gradient. This one here will have a smaller number for the gradient, and in fact, you know, if I make it like this, this is a very, very small gradient. It is not 0 because, as you can see, it's not perfectly flat. If it was perfectly flat, it would end up here rather than here, right? So that's just something to be aware of, that all we mean by the gradient of a straight line is how steep is it. If it's going uphill, it's positive, and if it's going downhill, then it's negative. So for example, if I move that there and that there, that's now quite steep, of course, but it's going downhill, so it's got a negative gradient. So that's the absolute basics of a gradient. There is then basically a little formula that we learn, which basically tells you how to work it out for a given line. Okay, so let me do that, for example, here. So the way we measure it is, and remember, we just want a number at the end. We say we go 1 along, and 1 along will mean positive 1 going along left to right. So left to right is positive. And then you ask, how far up do you go to get back to your line? Well, in this example here, I've gone 2 up. And so we just say this has gradient 2. So this one here has gradient 2. Okay, and it's as simple as that. Let me show you an example with a negative gradient. And I'll say it again. All of this was covered in videos shared 2 weeks ago. 2 weeks ago. So should not be new to anyone. So let me just make sure that's absolutely crystal clear. So let's have a look at this one. What's the gradient of this one? Well, we play the same game. You always start by going 1 along. And of course, we'll see trickier examples where you can't actually necessarily always go precisely 1 along. There's a more general version of this that I'll come on to. But this one's going 1 along, and now the question is how far up do we have to go? Well, of course, we're not going up at all. We're going down. But we're going to consider that as a negative up. As a negative up. So of course in real life you know you wouldn't say, oh, it's down. You would say it's down there. You wouldn't say it's negative up there, would you? Like, that doesn't make sense. You wouldn't say that in normal speech. However, in this context, we are going to consider going downhill to be the same as a minus up. So for us, this is basically 3 down is minus 3 up. And so this just has gradient minus 3. Because we went 3 down, basically. When we went 1 along, we went 3 down, so we'll say it has gradient minus 3. And this makes sense, of course, because it's going downhill, and we want downhill lines to have a negative gradient. So that works. So let me just finish this first thing here, this first idea, this idea about a gradient, with the absolute most general formula here for the gradient, okay? So let me get rid of this. And that, and then click on this and sort of move this to something more random. Okay, there we go. Right, so the absolute most basic definition for a gradient is this formula here, which is how far up, and if it went down, remember we're going to consider that up number to be negative, divided by how far along. So if you remember the one where it went 1 along and 2 up, well, that's also the same as 2 along and 4 up, or 3 along and 6 up. If you work out the up divided by the along for all of those options, you get the same answer. You get the same answer. So I might actually just quickly show you that. So here, we could say we've gone 3 along and we've gone 6 up. And if I do 6 divided by 3, I'll get 2, which is the same answer as if, for example, I'd go 4 along. And how far up will I have gone? This time 8 up. And 8 divided by 4 is again 2. So as long as you just pick something consistent, go however far along and however far up to get back to the line, you'll be able to work out the gradient, because you take the up number and divide it by the along number. And if it's going downhill, the along is still the same. It's still going to be going from left to right, but the up number will really be a minus because it's going down. Okay, so let's bring this back to where it was, or around about where it was. So the question is okay, what's this one? Well, this one looks like goes 1 along and we're not quite sure how far up, or 2 along and we're not quite sure how far up. 3 along and 2 up. Oh, great. So you see, as soon as you get some coordinates where it actually crosses at nice places, you can use this formula pretty straightforwardly, okay? So for example, this one here, let's say I start here and I say I go 3 along and then I go 2 up. So for me for this question, it's going 3 along, so that goes on the bottom, and 2 up, so that goes on the top, right? The up number goes on the top. So this line here has gradient 2/3. Okay, and then that's it. That's the answer. So that's how you work out the gradient of a line. I can't really say any more than that, to be honest. And you had loads of opportunity to practice that across Hegarty tasks 201, 202, 203 and 204, which are all covered in the playlist about gradients, which again I'll say is in the description. Right, so that was idea 1. Let's have a look at idea number 2. Which is basically plotting little formulas that have y and x in it. That's basically the next idea. So idea 2 is, you know, you could, again, pretend it's completely separate to the idea of anything to do with gradients, okay? So I'm going to say plot the graph y equals 2x add 3. So like, what on earth does this mean, someone might say? Well, hopefully you're not saying that because you've actually done all of the work. But if you haven't done all of the work, then let me just briefly explain what this means. So x and y tie in with the graph because of the, you know, the x and y coordinate, the axes, right? So x and y, okay? Now this by itself is just a formula. Now you're all quite good at formulas and quite confident with formulas. If I said, you know, here's a formula, y equals 2x add 3, can you tell me when x equals 3, can you work out y? Well, when x is 3, you're going to do 2 times 3 and then add 3, which is 6 add 3, which is 9. So you'd have had 9 for that one. You could have also been given a question, for example, when x is 7, what's y? Well, you do 2 times 7, which is 14, and then add 3, which is 17. So you'd have had 7, and what did I say, 7, 17. Now, basically, the way this ties in with graphs is these are now coordinates that's going to be on this graph here. So, for example, if you plot the coordinate 3, 9, so 3 along and then 9 up, there's a coordinate there. So here's where 3 is, here's where 2 is, here's where 1 is. That's the origin there, which is where 0, 0 is. So let's work out some more coordinates. When x is 2, what's y? So I'll do 2 times 2 and then add 3. So 4 add 3 is 7. So it would be 2 and then 7, right? Because here's 1, 2, 3, 4, 5, 6, 7, 8, and 9 there. Right, there you go. Let's also do x is 1. So when x is 1, y is 2 times 1 is 2, add 3 is 5, so you got 1, 5. And then let's do 0 as well. So when x is 0, y will be 3. So 0, 3 is this coordinate here. And then what you'll see is this sort of formula with y the subject and just something with an x in it, maybe plus a number, is always going to give you a straight line. Okay, we'll always give you a straight line because what you can now do is just basically join these up. And what you'll notice is there you go, you've plotted it, fantastic. It goes through all the coordinates that satisfy this equation here. So pick a random coordinate, let's pick this one. So what coordinate is that? That's minus 3, minus 3. Does minus 3, minus 3 fit this? Let's check. 2 times minus 3 is minus 6. When you add 3 to it, you get minus 3. So y would be minus 3 when x is minus 3. So that coordinate works there. You'd find all of them work. And that's the point. Okay, that's the point. Now, how do these two ideas link together? Is okay, well you do some practice with this just by itself. You do some practice just with gradients. That was the first thing we did. You do some practice of plotting, which is of course easier in class than it is on the computer, but that's what you had some practice at. And then the idea is to tie the two ideas together. As I say, we're going to tie together two key ideas. Basically, the way this ties together is when you've got it written with y the subject, which just means y is by itself, and then it's in terms of x. Basically, the number in front of the x is going to be the gradient of the line that you drew. So notice this one, how we go 1 along and 2 up. Well, that has gradient 2, which is what we want. And this will always work. And the reason it's always going to work is, if you make x be bigger by 1, how much bigger will y get? This is a question. In this example here, if you make x be 1 bigger than it was, what effect will that have on y? We can even answer that with algebra. Let me quickly show you. I think I'm going to break this into 2 videos, by the way. So this is kind of the overview video, and then the next video I will just go through the answers, okay? So if I replace x with x plus 1, so this is where x has gotten bigger by 1, it's gone up 1. The question is how much bigger has y gotten? Well, this is 2x add 2 add 3, which could be rewritten 2x add 5. Do you see how y was originally 2x add 3, but then we added 1 to x? And now y is 2x add 5? That's 2 bigger. That's 2 bigger than it was. This is 2 more after we made x be 1 more. So this means we go along 1, that's the x direction, and then up 2 in the y direction. That's what up means. We're on dealing with the y axis. And so this is basically always going to be the case, right? If this had been 5x, it would have a gradient of 5. If it was minus 7x, it would have a gradient of minus 7. It would be going 1 along, 7 down, 1 along, 7 down, 1 along, 7 down, etc. And then basically the other thing, before I finish this video, because it's probably quite long at this point. Yeah, I don't want it to be too much longer, that's for sure. This plus 3, well, if you think about it in the context of the formula itself, if you make x be 0, you'll be left with the plus 3. But when you make x be 0, that's when you're on the y-axis. If you think about all the coordinates on the y-axis, they all start 0 whatever, right? So you know you've got 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. They all have x being 0. So this plus 3 is just where it crosses the y-axis. And so what this means is when you get comfortable with these two ideas and can start to tie them together, is I could give you, for example, y equals 3x minus 1. So I could give you, let's quickly do it, be the last thing we do before I make my second video. The idea is to get to the point where I could just give you y equals 3x minus 1. Might do a different one as well, slightly trickier. We'll do y equals minus 3/4 x minus 2. So we'll have a look at two different ones. Y equals 3x minus 1. Well, it crosses at minus 1, and then it goes 1 along 3 up, 1 along 3 up, 1 along 3 up. So 1 along 3 up, 1 along 3 up, 1 along 3 up. It would have kept going like this. And you can just draw the graph really quickly, right? That's kind of the idea here. You can draw the graph really quickly. Okay, because I know this graph goes through minus 1 on the y-axis, and I know it has a gradient of 3, which means it's going uphill, 1 along 3 up, 1 along 3 up, 1 along 3 up. So the next question is a bit harder, but this is where we try to remember this formula. Gradient equals up over along. Now this number here is the gradient. It's the number in front of the x when you've made y be the subject. So for us, this is minus 3 up and 4 along, because the 4 number is on the bottom, and we want the along to be positive, going left to right. Minus 3 is the up, which means we're really going down. So let's first of all say, look, it's going through minus 2 on the y-axis, and then it basically goes 4 along, 3 down, 4 along, 3 down. Where's the 4 along and 3 down coming from? 4 is the along number, and 3 is the down number because it's -3 up, right? So that's 3 down. So it went 4 along, 3 down, 4 along, 3 down. And then that's basically it. There's not really a lot else to say. You can just do that. And then that's it. So I'm going to finish this video here. I would like you to go on to the next one to have a look at the questions being answered. Okay, see you later, guys. Bye-bye.